Good afternoon. My name is Deborah Olalary, and I am excited to present with you chapter 14 that has to do with perception. I wanted to go ahead and start with a quote by W.B. Yeats, and he stated that the world is full of magic things patiently waiting for our senses to grow sharper. I think, I think that that's a very powerful quote, given the information that is in this topic. And I have a couple quotes here and there that relate to what we might be learning about. So I just thought to put that in. So this chapter is pretty much going to discuss the psychological research on our senses, and they ultimately bypass a lot of the senses that have to do perception. We'll still go over that for a bit, but I did also want to touch on the cognitive neuroscience that also has to do with perception and everything else within. So I wanted to give us some key terms before we went ahead and started the actual um, presentation. So convergence is the act of moving toward union. You may hear me say that in some of the other slides. Stereopsis is envision, the impression of depth that is perceived when someone is seen or viewed through both eyes. And a binocular, you might be familiar with that, is using two eyes or a viewpoint, especially when trying to see a certain distance. APA defines perception as the process or the result of becoming aware of an object, relationship, or even events by the means of your senses, which includes activities such as recognizing, observing, and discriminating. So, with that being said, I wanted to start off with an activity. If you would go ahead and read the bottom triangle to the left hand side, give about a couple of seconds. Now, when you first look at it, it's going to say a bird in the bush. But if you caught it the first time, congratulations. But it actually has an extra the. And I thought it was very interesting how our senses kind of trick us to not see that word. And we'll also talk about why our brain does that. Next, we can go over to the other images. And My Wife and Mother-in-Law is a cartoon by W.E. Hill. And I wanted to ask you guys, what do you think it looks like? You obviously can't tell me, but I'm interested to know what you guys might perceive of the images below. Awesome. So I wanted to go ahead and talk about the human perception tools and how they're used. Now, this chapter doesn't go over the other perception tools such as taste, touch, smell, and auditory, but it does go over sight, which is one of the main perception tools that is actually talked about in this chapter. Edwin Boring calls the fact that we have two eyes, but we don't see double, one of the first mysteries of vision. And it had me thinking, like, wow, it is kind of interesting how we have two eyes and I don't see double. So went ahead and did some research and read on it, and it actually explained why. I also wanted to note that each sense of an organ is a part of a sensory system which receives sensory inputs and transmits sensory information to the brain. That's very important to note for later. So, how does the environment help humans sense information? Well, Richard Gregory explains that it generally depends on the perceiver's expectations, information, previous knowledge, and the stimulus itself. One of the major issues that psychologists generally had was that they were unable to explain how the process of physical energy moved to where your organs and were able to sense what was going on around you, and it ultimately led up to forming a foundation of perceptual experiences. And to the side, we have some images of some actual psychologists that we're going to be touching on, especially Gregory and Gibson with their top-down processing and their direct perception of the bottom-up approach. So now that we're talking about bottom-up processing, what is it? What do y'all think that it is? It's actually known as a data-driven process. It begins with something that stimulates something else, and from there, it's carried through the retina into the cortex, and it begins a stage where it hits a visual pathway, and whatever comes out of it is the analysis of what was put in. Um, so right here we have a meme, I wouldn't say a meme, more of an educational tool that speaks about the sensory data that's being brought to the retina. You see that she's observing the bee on the computer, and that data is being transmitted through her visual cortex, and it's actually being put out as a process because she's experiencing it, and you can see that she's thinking about it as well. Top-down processing is actually another form of processing that makes a lot of sense to me. So you have the sensory data, and you can think of it as someone like walking down the street at night and in a super dangerous neighborhood. You're gonna observe that data and you're gonna think about it. And based off your prior knowledge that has been stored in your brain, you're gonna understand that you are walking somewhere at night and it may be dangerous. And that is what we call the inference to the external world, as you can see. And because of that, it's going to aid with perception and action. A person may want to move on the other side of the road, or they may feel high on the fence, or they may even clutch their bag a little closer based off of what they know in situations just like that. And so you're going to use external you're going to use contextual information to recognize patterns that have happened or that might happen. Another example that I saw was writing in cursive, and the sentence in itself might be easier to read, but the word alone might be difficult because our brain is actually conditioned to be able to read things as a whole because like you're able to see the context clues of what it might says. And so the top-down processing, like prior knowledge suggests that it could be one of two things. It looks like a B or it looks like a 13. So how do humans determine depth of an object? This is something that I thought was quite interesting because I had never thought about it before. And one of the ways that they do is apparent size. So the question I asked here, well, many psychologists would ask is, how does one view the world in 3D when the retina is a 2D layer within the eye? So it talks about a stereoscopic vision. And when I did my research, I found some interesting facts about it. And I found that most predators have this kind of vision because it allows them to gauge the distance to hunt down their prey. But herbivores usually have eyes on the sides of their head because they're looking out for their predator or they're looking out for their environment. Either way, animals do not see depth the way that humans do. So 18 feet is usually about the best distance for an individual to use this form of vision because That's the amount that our actual brain can take in before we begin to use motion and size to determine depth. Individual eyes are like generally separated, which allow for differences in images to be observed, and the result of the depth of the image that is observed is therefore a stereoscopic vision. So we also have apparent size, and we're going to be able to understand the depth of something depending on the size of what is stimulating us within the retina, and most importantly, what's being perceived from a distance um, from the observer to the actual object. Perspective and interposition also allow for individuals to see depth when it comes to perception, because its gradient for perspective allows people to perceive things such as a railroad track being roughly the same size when they're closer, even though it's about a third of the side when you see far away. And interposition is when an object is hidden. We can generally realize that one object is being concealed, such as looking over a building and realizing that um, the building is closer or larger than the cars or the skyline or the airplane. So you're able to gauge how something is based off of the respective objects around it. So, how do we see form? Nerve fibers generally lead from both eyes, um, and they go to the same part of the brain. And although they see different images that might overlap, they're still able to do that. They do it by observing an image. So if you're observing an image, let's say you're looking at this wall behind me. After looking at this wall, the nerve fibers are actually going to lead from your eye to the same part of the brain. And this is called fusion within the visual cortex. So Edwin Boring actually came up with this, and it was one of the first mysteries of vision, and we spoke about it in the beginning of the presentation. And after finding all of this out, he led to the conclusion that we're going to perceive a single 3D image. And I have a fun quote back here that says, "Humans see what they want to see." Rick Riordan, The Lightning Thief. And if you have not read that book, I highly suggest you read it. So Irvin Rock was another young psychologist who was actually very, I wouldn't say famous, but he definitely led with experimental psychology. He started off with a square. So what he would do is he would show a square to the people that were coming to aid in his experiments. And when they would look at it um, at a 45-degree angle, it would show a triangle. So he would go ahead and tilt them as well. And as they would begin to tilt along with the object, they would feel themselves along with the room moving. And even though the square was back at a normal angle, they still perceived it as a diamond. And I feel like I said triangle before, but I meant to say diamond. Um, he concluded that one must understand that perception is on a psychological level before they understand it on a neuropsychological level. So before going in to get medical analysis, I'm assuming that they would go and see someone who could help them on a psychological level to observe what things that they might have going on. Then I have another quote by C.S. Lewis that says, which is the musician's nephew, and it says, "What you see and what you hear depends on a great deal of what you're standing. It also depends on what sort of person that you are." So, kind of gets you thinking, what kind of person am I to be able to see a square and think that it's a diamond, but you're human. That's just how your eyes and your brains perceive things. Uh, so I hope you enjoyed this presentation. I had so much fun working on it and understanding it. So if you have any more questions, I can't wait for you to ask them in this week's discussion.